Your shadow can outrun light. Try it. Hand, flashlight, wall, then flick your wrist. The shadow edge can race across a distant surface faster than 300,000 kilometers per s. So what just moved? And if it really beat light, why doesn't causality explode? Put your hand in front of a flashlight. Point it at a wall. You get the familiar little puppet show, a dark shape on the paint. Crisp at the edges if the light is small, fuzzy if the light is big. Now do the simple magic trick. Keep your hand roughly in the same place and sweep the flashlight sideways. The shadow races. If the wall is close, it just scoots. Nothing dramatic. But if the wall is far, really far, the same tiny wrist motion makes the shadow slide across meters in a blink. And if you want to be rude about it, you can scale it up until it looks illegal. Imagine a lighthouse on a coast, or a laser pointer on Earth aimed at the moon. The moon is about 384,000 kilometers away. If you rotate the pointer by a ridiculously small angle, the bright spot on the lunar surface can sweep across the moon faster than 300,000 kilometers per second, faster than light. And the shadow version is even more unsettling because a shadow feels like an object. It has a shape, it has an edge, it looks like a thing moving. So your brain whispers the forbidden sentence, something just went faster than light. But you also have another sentence in your head, drilled in like a commandment. Nothing outruns light. No matter, no energy, no message, no causal influence. If it did, relativity falls apart. Cause and effect gets scrambled. You can build paradoxes until your head hurts. So which sentence is wrong? That's the problem. That's the knot we have to untie cleanly without cheating. Because if you try to answer it with slogans, it's just an illusion. It's only a shadow. It doesn't count. You haven't actually answered anything. You've just soothed yourself with a label. What exactly is moving when a shadow moves? What exactly would it mean to break light speed in a way that physics forbids? And what's the difference between a thing moving and a pattern moving? Here's the first uncomfortable point. A shadow is not a physical object traveling through space. It's a description of where light is missing. It's a set of points on the wall that are receiving fewer photons than the neighboring points. That sounds like wordplay, but it's not. It's the whole game. A chair is made of atoms. If the chair moves, you can in principle tag one atom and watch it change position over time. There's a continuous identity being transported. A shadow doesn't have that kind of identity. There is no shadow stuff that flows from left to right. When the shadow slides, what's happening is that different parts of the wall are being lit, and different parts are being blocked at different times. So the moving thing is not a chunk of material, it's a boundary between lit and not lit. A boundary can behave very differently from a thing, but wait, does that automatically save us? Not yet, because even if the moving thing is just a boundary can still carry information, and information is what relativity really cares about. If you could use that racing shadow edge to send a yes-no signal to someone far away faster than light, blink once for yes, twice for no, then you've built faster than light communication. Whether you call it shadow stuff or absent stuff wouldn't matter. Physics would still be in trouble. So we have to be precise about the real claim of relativity. Relativity does not say you will never see anything appear to move faster than light. You do see things like that. You can make them in your living room. A pair of scissor blades closing can have a crossing point that moves faster than light if the blades are long enough and close quickly enough. A laser spot on a distant screen can sweep superluminally. A wave of stadium applause can look like it's traveling at some crazy speed if you define the front in a certain way. Relativity says something sharper and much more brutal. No information, no energy, no matter, no causal influence can propagate faster than light. It's not a speed limit on apparent motion. It's a speed limit on cause and effect connections between events in space-time. So the real question becomes, when the shadow edge moves, is any single physical influence traveling along the wall faster than light? Is any point on the wall causing the next point to darken, like dominoes? Or are those points being controlled independently by the flashlight, with light traveling to each of them at speed c? And that word independently is the hint. Let's freeze the scene into something you can picture. You have a flashlight at one point in space. You have a wall some distance away. Between them, your hand blocks some of the rays. The shadow on the wall is the set of points that lie behind the hand, along lines from the flashlight. Now you rotate the flashlight slightly. That changes which lines hit which points. The shadow boundary on the wall shifts. If the wall is far away, a tiny change in angle translates into a huge change in position on the wall, like a long lever. Small motion at the handle, big motion at the tip. That alone already tells you how the superluminal number appears. Speed is distance over time. If the distance on the wall can be enormous while the time is small, the ratio can exceed c. But physics doesn't care about that ratio by itself. Physics cares about what had to happen in order for the wall over there to know it should be dark. And the only way the wall can know anything is through light, photons traveling from the flashlight region to the wall region. Every point on that wall is getting updated by new photons arriving. Those photons left the flashlight earlier. They took time to cross the gap. Nothing about rotating your wrist changes the fact that information about your wrist position only reaches the wall at light speed. So how can a shadow edge possibly jump across the wall faster than light if the news can't? Because you're comparing two different points on the wall as if the shadow traveled from one to the other, but it didn't. The wall point on the left became bright because photons that were not blocked reached it. The wall point on the right became dark because photons that were blocked failed to reach it. Those are two separate light paths controlled by the geometry at the flashlight and the hand. There is no physical requirement that the darkness at the left must be carried over to the right like a baton. Each point is decided by whether its line of sight to the flashlight is clear at the moment the relevant photons pass by your hand. So the shadow edge is more like the place where a decision flips, not a thing that travels. Now, if that sounds abstract, good, it should. Your intuition is trying to treat the shadow as a moving object because it looks like one, but physics doesn't care what it looks like. It cares about what mechanisms are available to connect distant events. Here's the clean way to say the puzzle we must solve, without any philosophy. 1. It is easy to arrange for the asterisk position asterisk of a shadow edge on a distant surface to change so rapidly that distance over time exceeds c. 2. Yet it should be impossible to use this setup to transmit a controllable signal from one place to another faster than c. Those two statements must both be true. If either one fails, you either lose a real effect you can demonstrate or you break relativity. So where exactly is the catch?
The catch is hidden in a word people use casually: move. A chair moves when the same chair is later over there. A shadow moves when the wall point that used to be dark is later bright, and another wall point that used to be bright is later dark. That's not one entity traveling. That's a change in a pattern. Patterns can have phase velocities that exceed c. That's allowed. What's not allowed is signal velocity, the speed at which you can push a new piece of information into the pattern and have it show up somewhere else. And even that sentence has teeth, because you might say, fine, I'll put a little notch in the shadow, a recognizable mark. Then I'll watch that mark fly across the wall. Isn't that information moving faster than light? That's exactly the kind of sneaky move we have to confront. Not in a hand-wavy way, in a merciless way. Because a notch in a shadow is still not a thing. It's still a set of wall points receiving fewer photons. To make the notch appear at some far location, the photons that would have illuminated that notch must be blocked or unblocked at the right time. And the only place you can do that blocking is near the hand, near the source, before the photons have even left for the wall, which means the instruction for the notch to exist at that far spot has to be encoded into the light field earlier, and it still propagates at c. So the superluminal sweep is real as a geometric effect, but it's not a superluminal asterisk transfer asterisk of a causal influence along the wall. That's the problem definition. That's the target. We're going to keep our promises to physics. No faster than light messages, no hidden loopholes, no maybe relativity is wrong. And we're also going to keep our promise to your intuition. Yes, the shadow can have a speed bigger than c in the plain dumb arithmetic sense, and it will not be a trick of camera frames or reaction time. It will be a lesson in what speed even means when the thing you're tracking is not a physical object but a moving boundary defined by light arriving from different directions at different times. So let's build the simplest honest model. No magic words, just geometry and timing. Picture a flashlight at point S. A wall is a flat screen some distance away. Call that distance L, and your hand is somewhere in between, closer to the flashlight than the wall. Now pick one tiny spot on the wall. Call it point A. Whether A is lit at some moment depends on one thing. Did photons that left the flashlight earlier manage to travel in a straight line to A without being blocked? That's it. A doesn't ask the neighboring points what they're doing. A doesn't receive darkness from the left. A is only responding to photons arriving from S, which immediately forces you to respect a delay. If the wall is lit meters away, then whatever the flashlight is doing right now cannot affect the wall until about L seconds later. Light has to cross the gap. So if someone stands at the wall with a stopwatch and you flick the flashlight, they won't see it instantly. They see it after the travel time. Good. Now where does the superluminal number come from? It comes from the fact that different points on the wall correspond to different directions from the flashlight. If you rotate the flashlight by a small angle, delta theta, the beam's intersection point on the wall moves sideways by approximately delta x approx L, delta theta. for small angles. That's just the long lever effect. Far wall means tiny angle becomes big displacement. Now do it in time, delta t. The spot speed on the wall is v spot approx frac delta x delta t approx frac L delta theta delta t. There's no law of nature in that formula. It's just a ratio. If L is huge and you can rotate the flashlight fast enough, you can make that ratio bigger than c.
Notice what didn't appear anywhere in that calculation: photons traveling sideways along the wall. The photons that light point A are not the same photons that light a nearby point B a moment later. They're different photons launched in different directions. So the spot is not a thing sliding, it's a place where light happens to land. Now swap bright spot for shadow edge. Same geometry. The shadow edge is the set of wall points where the line of sight from S just grazes your hand. As you shift the hand or rotate the flashlight, that grazing line sweeps across the wall. Again, the distance swept can be huge even if the hand motion is modest. And your brain says that edge is moving. But in the mechanism, nothing is traveling along the edge. Each wall point is deciding its own fate based on whether its own ray from the flashlight is blocked. Okay, still feels like we're dodging, because you could say, fine, maybe the spot is just geometry, but I can still manipulate it, I can make it do patterns. So surely I can encode a message and send it faster than light. This is where people get sloppy. So we're going to be painfully careful. What counts as a faster than light message? It's not something changes over there after I do something over here. That happens all the time in boring ways. You clap and someone across the room hears it later. You turn on a lamp and someone sees it later. The forbidden thing is, you choose a signal here at time, t_0, and a distant observer receives that choice at a time earlier than light could have carried it. So imagine two observers on the wall, Alice at point A on the left, Bob at point B far to the right. The distance between A and B is d. You stand near the flashlight with a switch. You claim, I can make the shadow edge sweep across the wall faster than light, so I can send Bob a message in less than dc. How would you try? The naive idea is make the shadow edge hit Alice first, then Bob. If the edge travels faster than d, Bob gets the event quickly. Then Bob learns something. But learns what? If all Bob sees is a shadow edge arrived, that's not information from Alice. That's just Bob seeing the flashlight setup changing. To send a message, you must have a controllable choice. Edge arrives or doesn't arrive, notch up, notch down, two different patterns. Something with alternatives. So let's give you every advantage. You control the flashlight and the hand. You can make the shadow edge sweep. And you can choose at the last moment to insert a special feature, a kink or pulse on the moving edge to represent a bit. Now Bob watches his patch of wall. He waits for the pulse. If it arrives, that's a 1. If it doesn't, that's a 0. If Bob can reliably read your choice sooner than light travel time, you've broken relativity. So why can't he? Because for Bob's wall point to show the pulse, something physically has to be different about the photons arriving at Bob. Either fewer photons arrive, it gets darker, or more photons arrive, it gets brighter, or the timing changes, or the spectrum changes, whatever. But it must be carried by electromagnetic influence from your region to his region. And that influence is limited by C. Here's the key timing fact that kills the loophole. To change what happens at Bob at time t_b, you must have changed something near the flashlight region at time t_b minus LC, or earlier, because the photons that reach Bob at t_b left the source region earlier. You cannot reach back in time and alter them after they've passed your hand. So if you say, I will decide at the last moment whether to include the pulse, the last moment for Bob is not right before Bob sees it. The last moment is right before the relevant light rays pass the hand, which is much earlier, and when the wall is astronomically far, that last moment is astronomically early. That's the practical version. But there's an even cleaner way to see it. Think of the wall as a grid of independent light sensors. Each sensor is connected only to the flashlight by the path light takes. There is no wire between sensors. When the shadow edge sweeps, you are not sending a signal from sensor to sensor. You are addressing each sensor directly from the source, with a different beam direction. So the apparent speed across the wall is not the speed of a transmitted influence. It's the speed at which your addressing direction changes. It's like aiming a hose at a line of cups. You can flick your wrist and select which cup gets water. The wet spot can jump from cup to cup faster than the water flows sideways along the table, because the water isn't flowing sideways along the table at all. It's coming from the nozzle to whichever cup you choose. Now, why does it still feel like cheating? Because when the wall is far, the spot seems to sweep continuously, not jump.
It feels like a thing with continuity. Fine, let's analyze continuity. Take two nearby points on the wall, separated by a small delta x. The shadow edge reaches them at times separated by delta t. The ratio delta x delta t can exceed. Does that mean the event at the first point caused the event at the second? No, because both events share a common cause, the geometry of the hand and the flashlight at earlier times. They are correlated, not causally linked along the wall. This difference, correlation versus causal propagation, is not philosophical. It is enforced by the structure of space-time. If you draw the light cones, each wall event lies in the future light cone of some region near the flashlight. But the two wall events need not lie in each other's light cones. If the sweep is superluminal, one cannot causally influence the other. They're like two bulbs turning off because the same power station cut the line, not because bulb A shouted to bulb B. Now comes the part people miss. Even a moving edge has different kinds of speed. There's the speed of the asterisk phase, asterisk of a pattern. That can be anything, infinite even. You can arrange for a sinusoidal interference pattern on a screen where the bright fringes shift with an arbitrarily large apparent velocity. If you adjust the relative phase of two beams quickly, the fringe motion can outrun light because no energy rides on the fringe itself. Then there's the speed of the front. The first moment a change can be detected, the arrival of new information that wasn't predictable before. That speed, the signal speed, is limited by SU. So here's a sharp test for your shadow. Can you create a sudden, genuinely new feature, something that didn't exist anywhere on the wall before, and have its first appearance sweep superluminally in a way that lets Bob detect it early? You might think yes. You might say, I'll suddenly raise my hand and create the shadow edge from nothing. That edge will appear and sweep. But when you actually time it, the first appearance at each wall point happens only after the corresponding light rays have had time to travel from the hand region to that point. Every point waits its own delay. The creation of the shadow is not launched along the wall. It is launched from the blocking event, then carried by light to each point. And if you want the edge to appear at two far separated points with a tiny time difference, so tiny that it implies superluminal sweep, you need those points to correspond to rays that diverge by a tiny angle, meaning they were decided by nearly the same region near your hand, meaning the causal origin is common, and again nothing traveled between the wall points. So yes, the shadow edge can have an apparent speed larger than, but the earliest moment Bob can learn anything you chose is still limited by the time it takes light to carry the consequences of your choice to Bob. There's still a lingering itch, though. A really stubborn one. What if we use two flashlights? Two sources far apart. Could we arrange a shadow edge that is steered from two sides so the edge location depends on a choice made far away, and then make that dependency show up elsewhere faster than light? That's the kind of question that separates I memorized a fact from I understand the structure. Because now we're going to hit the real heart of it. When you try to make the shadow carry a bit, you end up needing an asterisk meeting point, asterisk of influences, and that meeting point is constrained by light cones. And that's where the apparent superluminal motion finally meets the wall called causality. So let's push it to the edge where it feels like it might actually work. Two flashlights, two people, two choices. Put flashlight S1 on the left, flashlight S2 on the right. They both shine onto the same distant wall, and in front of each flashlight there's a hand, or a shutter, something you can flip quickly. You might think, now I can do something clever. I can make a shadow boundary that depends on what S1 is doing and what S2 is doing, and if I coordinate them, maybe I can make the boundary jump around, and maybe someone on the wall can read a message before light should allow it. This is where relativity stops being a slogan and becomes a geometry problem. Any visible pattern on the wall, bright, dark, shadow edge, interference fringe, exists because electromagnetic influence from sources arrived there. If two sources contribute, then what you see at a wall point is determined by the sum of what arrived from S1 and what arrived from S2. And here's the catch that kills every faster than light scheme. For a wall point to depend on a choice made at S1 and S2, the wall point must lie in the future light cones of those choices. It has to be reachable by light from both events. There is no other mechanism available, no shortcut through the wall, no message through the shadow. So any feature on the wall that encodes something about both choices can only appear after enough time has passed for light from both places to arrive. That's not philosophy, that's wiring, nature's wiring. You can't build a device where the output depends on an input that hasn't had time to arrive. Now you might say, fine, I won't make it depend on both. I'll make it depend only on S1. I'll use the superluminal sweep of the shadow edge as a messenger from left side to right side on the wall. But the moment you say messenger, you're assuming a causal chain along the wall, and there isn't one. The
The wall is not a highway for influence, it's a billboard. The wall doesn't transmit the shadow, it displays the shadow. Every point on it is being updated by incoming light from elsewhere. So the wall is like millions of little clocks being set by distant signals. If you look at the pattern of their readings, you can see something that looks like a wave traveling across them, but the clocks are not talking to each other. That's why the shadow speed can be enormous. It is not limited by how fast anything travels from one wall point to the next, because nothing is traveling from one wall point to the next. It's limited only by how fast you can change which rays are blocked and how big your lever arm is. Now let's answer the emotional version. The thing you actually feel when you watch the shadow race. It feels like a violation because we use the same word move for two very different situations. When a cat runs across the floor, the cat's atoms occupy a sequence of positions. There is a continuous identity moving through space. If the cat runs at speed v, the cat carries energy and momentum at speed v. If v exceeded c, you'd have a real crisis.
When a shadow edge runs across a wall, there is no continuous identity moving through space. There's no conserved shadowness sliding along. There is only a sequence of separate points on the wall changing their illumination state. So the speed you're computing is not the speed of a thing, it's the speed of a change in a pattern. And patterns can be slippery. Here's a clean analogy that doesn't pretend to be more than it is. Imagine a long row of mousetraps, each one loaded with a ping-pong ball on top, and each trap is triggered by a light sensor. The sensors don't talk to each other. They each only react when they see light. Now you stand at one end with a flashlight and sweep it down the line. The traps pop in sequence. If the line is long enough and you sweep fast enough, the pop front can travel faster than sound, faster than the speed the springs could transmit anything down the line, even faster than the speed you could run. But no trigger signal traveled down the line. Each trap was triggered directly by the flashlight beam that reached it. That's your shadow. The wall is the line of traps. The illumination is the trigger. The edge is the pop front. Now can you send a message to the far end by how you sweep? Only at the speed the beam's influence can arrive at light speed from the source to that trap. You can make the front asterisk appear asterisk to zip, but the earliest moment the far trap can know anything is still limited by when photons arrive there. So if someone at the far end asks, "When did you decide to send me that bit?" the answer is, you had to decide early enough for photons encoding that decision to make the trip. No exceptions. Now let's go back to the moon example because it's the one that makes your stomach drop. You shine a laser at the moon, you wiggle it, and the spot moves across lunar dust at say 10 times the speed of light. Did anything on the moon move that fast? No, the dust didn't, the photons didn't, the laser apparatus didn't. What happened is this: at one moment you aimed at lunar point A, so photons were sent along direction A. A little later you aimed at lunar point B, so photons were sent along direction B. Those two sets of photons travel at speed c, along different paths, and arrive at different places. The spot speed is just the mapping from your angle to a position on the moon. It's a coordinate speed, a geometric speed. If you try to put information into the spot, say you want to draw a letter on the moon that someone there can read, the earliest time they can read it is when the light carrying that letter has arrived, which is still about 1.3 seconds after you send it. Always, no matter how fast the spot seems. So what's the final verdict on the original claim? Your shadow breaks light speed. In the everyday arithmetic sense, yes, you can make the position of a shadow edge on a distant surface change so fast that the ratio distance/time exceeds c. But in the sense physics cares about, transport of energy, matter, or information, no, not even close. Nothing traveled faster than light because there was nothing to travel. There was a relabeling of which points are lit, and if you want a single sentence to carry in your pocket, it's this: a shadow can move faster than light because a shadow isn't a thing. It's an answer to a question: did light get here? And different points can get different answers without any sideways communication. Now the existential payoff, the part that's easy to miss if you treat this like a cute paradox. Relativity is not really about speed limits. It's about causality. It's about what can influence what. It's telling you the universe is stitched together in a certain way. Events are connected by light cones. If you're outside my light cone, you are in a very strict sense not reachable by my choices yet. Not because nature is being stubborn, because the structure of space and time forbids the connection. And the shadow trick is a perfect demonstration of how your brain tries to cheat that structure with a picture. You see a boundary sweep, you think object, you compute a speed, you think law broken. But the law wasn't about pictures, it was about what can cause what. So the next time you see something moving faster than light, don't rush to defend relativity with a slogan. Do something better. Ask, what is the physical carrier here? What is actually being transported? Where is the energy flowing? Where is the information being created, and how does it get to the observer? If you can't point to a carrier, you're probably watching a pattern, not a projectile. And that's not a loophole. That's one of the deep lessons of modern physics. The world is not made only of little billiard balls moving around. It's made of fields, constraints, correlations, and the geometry of space-time itself. If you want more of this, more of these looks impossible but isn't moments, stay with me, because the universe is full of things that seem like violations until you ask the right question. And the right question is almost always what actually has to travel.